Hello students. Today, now in this lecture, we are going to continue with the Newland's law of octave. We'll continue with the same chapter, that is periodic classification of elements, students. We have already done till Dobereiner triads, so now we are going to continue with Newland's law of octave, students. When we'll start with the Newland's law of octave, students, first I'll explain you something about music, students. Now we'll see music in physics. Yeah, students, here there is need to learn, so that's why I'll explain you something about music, and then we'll continue with the Newland's law of octave, students. Students, when you will see Indian music system, Indian notation, in Indian notation, students, in Indian music system, there are seven main notes, students. There are seven main notes are there. Seven main notes are there. Seven notes are there, and these notes are sa, re, ga, ma, pa, dha, ni. Students, these notes are sa, re, ga, ma, pa, dha, ni. Sa, re, ga, ma, pa, dha, ni. In the same way, when we'll talk about, students, here what happens, students, when we start from sa and we'll move towards ni, students. When we'll start with sa and we'll move towards ni, from sa, re, ga, ma, pa, dha, ni, what happens, students? Frequency increases. Frequency increases, students. Sa, when you will reach to re, the frequency is increased. Then ga, more increase. Ma, frequency is continuously increasing, students. Pa, dha, ni, students, when you will continue, when you will reach to the ni, when you will reach to the ni and there is further increase in frequency, you will able to hear the same sound again. You will able to hear the same sound again. Again sa, re, ga, ma, pa, dha, ni. It will continue, students. And after ni, when you will increase the frequency, when you will increase the frequency, again you will able to hear the same sound sa. So here what happens, students, when you will start with sa and you will keep on increasing frequency, you will able to hear re, ga, ma, pa, dha, ni in order, students, in order. And once you will reach to ni, students, and still if you will increase the frequency, again you will come back to the same frequency sound sa. Though frequency is now different, but you will able to hear the sound same sa. So here when you will see this, the frequency will be doubled here, students. Frequency will be doubled. So here frequency will be double, but the sound will be same, that is sa. So here same thing happens in Western notation also, students. In Western notation also same thing happens. When you will start with do, and you will continue increasing the frequency, you will able to hear sound re, mi, fa, so, la, ti. In this way, the frequency will, as you will keep on increasing frequency, you will able to hear the sound do, re, ma, fa, so, la, ti in order, students, in order. And when further if you will increase after ti, once you will able to hear t and still you will increase the sound, what happens, students? The same do will be repeated, same sound do will be repeated. And again if you will keep on increasing the sound, you will able to hear re, mi, fa, so, la, ti. Still if you will increase, again you will able to hear the same sound do. So it happens, students, it happens. This is something about music, students, whether it is Indian notation or Western notation, same thing happens here, students. Now when we'll talk about Newland, what he did, Newland did the same thing. What he did, he arranged the elements in the increasing order of their atomic masses, and what he found, he said that after 7, every eighth element is having same property as the first one. So here when he started with hydrogen, lithium, barium, boron, carbon, nitrogen, oxygen, after oxygen, 8 element he kept just below the hydrogen only, and he said that the fluorine will have the same property of hydrogen. And again he started to continue with sodium, magnesium, aluminium, silicon, phosphorus, sulfur. And again when he reached to cobalt and nickel, he found that both are having same property, so he kept below the same column, he kept it in a same column, and in this way he arranged the all elements in the increasing order of their atomic masses, repeating every eighth element just below the previous first element, students. So here in this way he arranged all the elements. But when he arranged all the elements, he said the every column is having same property, every column is having same property. For example, when we are talking about hydrogen, fluorine, chlorine, bromine, cobalt and nickel, all are in a same common column, students. When you will see first column, according to him, he said hydrogen, fluorine, chlorine, cobalt, nickel and bromine, all are having same property, as they are falling in a same column. In the same way, when you will see, students, lithium, sodium, potassium, copper, this all will have, students, same property. This all will have same property as they are falling in a same column, students. So here observed a pattern. He was the one who observed the pattern first time. He observed a pattern that was periodic means which is going to be repeated after the interval of some numbers or some time. So here he was the one who observed this first time, that the properties are periodic function, and he was the one who tried to arrange the elements in a periodic pattern, students. Here he called this method of arranging elements as the law of octaves, as it was matching, it was compared with the octaves of music notations, students, sa re ga ma pa dha ni, or you can say in western, in the same way, western music. So he compared the increase in atomic masses or arrangement with the music notes, and that's why he named the pattern as a law of octave, because the pattern repeats every 8 elements, students. Now here later, when elements are arranged in the order of increasing atomic mass, the properties of 8 elements starting from any given element are repetition of the periodic properties of the first element. According to him, what he said, whenever you can start from any element, when you will reach to the 8th element, you will find that the element is having same property as the first one, students. Let us see the limitations. When he arranged all the elements, there were few repetitions, students, limitations of the Newland's law of octave, students. Here many limitations were found in Newland's octave. This law was found to be applicable only up to calcium. When he arranged the elements, students, many limitations were there. Out of those limitations, few are listed here, students. This was found to be applicable only up to calcium. Later on, after calcium, when you will see, after calcium, till calcium, the law was followed, the law was applicable, and he could arrange till calcium only. Later, after calcium, the law was not effective, and it was not followed, students. It was not followed. So it was the first limitation, students. Newlands fitted all the known elements in the table of 7 into 8, that is 56 boxes. Newlands placed 2 elements each in same box to accommodate all the known elements in the table. He wanted to accommodate all the elements in the same table. That's why what he did, in 2 boxes he kept two elements. For example, cobalt and nickel he kept in a same box, and in the same way cerium and lanthanide, here La and Ce are kept in a same box, students. So here cobalt and nickel, Co and Ni, and second Ce and La were kept in a same box. It was the second demerit. Moreover, he placed some elements with different properties under the same note in the octave. For example, Newlands placed the cobalt CO and nickel under the note do along with the halogens, while iron having the similarity with the cobalt and nickel always from them along away from them along with the non-metals. So here cobalt and nickel, these were the metals, they were kept with the halogen, and iron was having the same property, was kept with the non-metal, that is oxygen, sodium. So here non-metals are kept with the metals and metals are kept with the halogens. So under the note Ti also, Newland's octave did not have provision to accommodate the newly discovered elements. He could not answer for the elements who are going to be discovered. What will he do if the new elements are discovered, students? So here in this way, this was the another demerit. The properties of the new elements discovered later on did not fit in the Newland's law of octave, and the Newland's law of octave was rejected by the scientific world of that time, students, of that time. And later on, the new scientist who came forward with the new theory, the name is Mendeleev. He gave one more theory, and the theory of Mendeleev we are going to continue now, students. Here small introduction is there about the scientist Demerit Mendeleev. 1834 to 1907 was a professor in the St. Petersburg University. He made a separate card for every known element showing its atomic mass. He arranged the cards in the accordance with the atomic masses and properties of the elements, which resulted in invention of the periodic table of elements, students. What he did, whatever elements were there, for each element he made separate cards, and on those cards he wrote the names, properties and atomic masses, students, and then he arranged the cards in the increasing order, students, in the increasing order of their atomic masses, students. Now Mendeleev's periodic table, when we are talking about Mendeleev's periodic table, this law states that the physical and chemical properties of elements are periodic function of their atomic masses. That means what he said, that the properties, whatever properties, whether it is physical or chemical properties are there, it is going to be repeated. It is a periodic function, students, as the first Newland said that it is periodic, but he said that it is repeated after 7. Eighth one is having same property, but here he did not add this word. He just said that this is the physical, and here the physical and chemical properties are periodic function. He did not, he just removed the word eighth element. That means he said the properties are periodic, but every eighth element is not having the same properties, students. So here there was some change, and with that change he started to arrange the elements. He developed periodic table during the period of 1863 to 1872 AD. He considered the atomic masses as the fundamental property of elements. He was working on the basis of atomic masses. He was trying to arrange the elements as per the atomic masses, students. Now what he did, students, he started to arrange elements. He took the first element which was discovered till that time, and he kept in a one row, students. He kept in a one row. Then when he saw the second element was having the same property as the first, so he kept just below the first. And then third was not having property same as one, so he kept the next. And then in this way he kept all the elements in the increasing order from left to right, students, left to right. Later on, when he saw the next element is having same property as first one, so he kept the sodium just below the lithium. And then again he saw magnesium is having same property, he kept it below the barium. And in this way again he moved and he kept on arranging the elements. Later on, potassium was having the same property, so he kept before the below the sodium. Calcium was having same property, so he kept just below the magnesium. But when he saw titanium was not having the property same as aluminium. He saw that titanium is having property same as silicon, so he left the space in between and he kept the titanium next to the just below the silicon, and in this way he continued arranging, and when he saw the again property is having same as potassium, he kept copper just below the potassium, and in this way he arranged all the elements in the increasing order of their atomic masses, and in between he left a few empty spaces wherever he did not get any element having the same property according to that column. And when the table was completely done, he said that those empty boxes are there for the elements who are yet to be discovered, and in this way he arranged all the elements, all elements, and he was appreciated for this work, students. He was appreciated, and it was accepted by the group of lobby of scientists of that time. Here merits of the Medlev periodic table we'll see. Atomic masses of some elements were revised so as to give them proper places in the periodic table in accordance with their properties. For example, previously determined atomic mass of beryllium was 14.09, and later on he said that the mass is not 14.09. He proved that the atomic mass is 9.4, and he, in the same way, beryllium was placed before boron, and he changed the place of beryllium. So this was the one merit of Medley periodic table. He arranged the elements as per the proper atomic mass. He gave the proper atomic mass, students. Now later on, Medley kept vacant places also. He kept vacant places. In vacant, as we saw, students, when you will see here, vacant places are there whenever he did not get the atoms matching with the same group property. He kept the places empty only. He did not do any changes. And later on, he said that Mendeleev kept vacant places in the periodic table for the elements not discovered till then. The elements who are not yet discovered, he kept the places for them. Three of these unknown elements were given the names Eka boron, Eka aluminium, and Eka silicon, and he predicted the properties of three elements out of those empty boxes, students, yet to be discovered. He predicted the properties, and he gave the names to those elements, students. He gave the names as Eka boron, Eka aluminium, and Eka silicon for the known neighbors, and their atomic masses were indicated as 44, 68, and 72 respectively. He predicted the atomic mass also. Not only this, but also he predicted the properties were also predicted, students. He predicted the properties were also predicted. Later on, these elements were discovered and named as scandium, gallium, and germanium respectively. The properties of these elements matched well with those predicted by Mendeleev. So whatever he predicted, later on when they were discovered, they were discovered and named as scandium, gallium, and germanium, it is found that the prediction was quite good, and it is approximately same. It was approximately same. So here that was the again second merit of the Mendeleev periodic table. Here, students, a list is there of two here. Eka aluminium was the predicted name, and here these are the predicted properties, students. At the same time, when the element was discovered, it was named as gallium, students. It was named as gallium, and properties are here as follows, students. Now when you will see here, it was predicted by him 68, and it is 69.7. so here atomic mass is approximately same only, students. There is only difference of 1.7, which is considerable, we can consider, because that time element was not discovered, and still he predicted the mass, and it is quite near to the real atomic mass, students. At the same time, density, when we will talk density, he said that 5.9, and later on when it was discovered, it is found that it is 5.94. see here, 0.04 difference only. So it is exactly same, we can say, students. At the same time, melting point, he said that it should be low, and later on it is discovered as 30.2. it is approximately the room temperature, students. It is our room temperature when we are in Maharashtra, students. When we are in Maharashtra of India, you will find that it's approximately same as the room temperature. Formula of chloride, when we are talking about formula of chloride, when the this element reacts with the chloride, the formula was named as ECl2. Later on, when it was discovered as gallium, the only change is that instead of E, Ga is there. Instead of Ga is there, because it was predicted and named as gallium. Otherwise it is same, students. So here there is only change in name, nothing more than that. So again the property is same. At the same time, oxide, when we will see oxide, again here E is there and here Ga is there, because it was named as gallium. The person who discovers that person names the element, students. So here name was gallium, and previous name it was predicted as Eka aluminium. So here there is difference in E and Ga only. Otherwise it is same, students. Formula is same, molecular formula is same. Nature of oxide, when we will talk about nature of oxide, it is same. He that means Mendeleev predicted that the nature of oxide must be amphoteric oxide, and later on when it was discovered, it is found that is the nature is amphoteric oxide only. So here again the nature of oxide is also same. So it was he predicted everything in a exact way, and his prediction was right, and that's why it was a second demerit, it was the second merit of the Mendeleev periodic table, students. Let us see the third point, third merit of the Mendeleev periodic table. There was no place reserved for the noble gases, students. For noble gases, he was not having any place in his periodic table. In Mendeleev original periodic table, there was no place. However, when the noble gases such as helium, neon and argon were discovered toward the end of 19th century, students, just imagine, he did his all works in the 18th century, students, in the 18th century, and at the end of the 19th century, approximately 50 to 60 years later, when it is discovered in 19 and end of the 19th century, when it was discovered, Mendeleev created the zero group without disturbing the original periodic table, in which the noble gases were fitted very well. Students, when you will see here, you can see here eighth group. He arranged the elements, noble gases, in eighth group, students, eighth group, and he arranged all the elements in the zero group, students, in the zero group. So whatever places were empty, he kept noble gases in the zero group, students, in the zero group. So in this way here, sorry students, this is not zero group. I'll show you where is zero group when I'll show you this table. Yeah, here this is the table. Here eighth group is there. Later on, eighth group, there was no place for the noble gases, but he made the group, one extra group at the end of eighth group, and named as zero group. He named as the zero group, students, and he arranged the elements in the last column, students, last column. He did not disturb his table. In this way, he was the one who successfully arranged all the elements. Even 19th century, he was having option what should be do with the zero group elements. He arranged the zero group elements in the last column. He created the separate column for the zero group element, but he did not disturb the modern his periodic table. And in this way, periodic table, he arranged all the gases in that last column, student, in that last column. So this was the again merit of the Mendeleev periodic table, students. Later on, now it is not like that only merits were there were few demerits in modern periodic, in Mendeleev's periodic table. And let us go through what was the demerits, students. So few demerits were also there in Mendeleev periodic table. So let's see which demerits were there, students. Here when you will see demerits of Mendeleev periodic table, the whole number atomic mass of the elements cobalt, Co and nickel Ni is the same, students. When you will talk about atomic mass, there was the difference in points, students. There were this difference in points, but when you will take approximate value, the whole number atomic mass was same. Atomic mass was same. Therefore there was an ambiguity regarding their sequence in Medley periodic table. What should be done if they are having same atomic mass? Who will be kept first and who will be kept second, students? It was a question mark. Isotopes were discovered long time after Medley put forth the periodic table. As isotopes have the same chemical properties but different atomic masses, a challenge was posed in placing them in Medley periodic table. When later on, when isotopes, students, when we are talking about isotopes are the element of same elements are there, but their atomic masses are different, students. Now what should be done if the same element is having different atomic masses? We are arranging the elements in the increasing order of atomic masses, so we should give the different place to the same element. But if we'll give the different places to the same element, the table will be disturbed, totally disturbed, and it was the second demerit. So he had to keep the all the elements with the same different atomic masses in a same group. So it was a second demerit. When elements are arranged in an increasing order of atomic masses, the rise in atomic mass does not appear to be uniform. Students, when you will see rise in atomic mass, it was found, suppose one element is having mass of 2 atomic mass unit, second next one is having 3 atomic mass unit, and next one is having 5 atomic mass units. So when you will see 2 and after 1 3 and after 2 5, so here one difference is there, here 2 difference is there. So difference was not regular, students, difference was not regular. So here when he arranged the atomic masses in the increasing order, rise in atomic mass was not appeared to be uniform. It was not possible therefore to predict how many elements could be discovered between two heavy elements. So it was very difficult to predict how many are the elements yet to be discovered between the two elements. And later on, because of this, see here, students, one more demerit is there. It is related to position of hydrogen also. Here when you will see the position of hydrogen shows the similarity with the halogen, students. Halogen, when we are talking about halogen, what is halogen? A seventh group 7 is called as halogen, students. I'll show you the table. When you will see table, students, the seventh group group is called as halogen, students. So here when you will see the hydrogen, the properties of hydrogen were matching with the first group, and not only first group but also with the seventh group. So it was a big problem, where should we keep that hydrogen, either in first group or in seventh group, because hydrogen was having the property similar to first and seventh, both the groups. So it was again a problem for him to arrange the hydrogen, to give the position of a hydrogen atom, students, to give the position to the hydrogen atom. Friends, when you will see in this table, here the compound of hydrogen is compared with the compound of sodium, students. When hydrogen reacts with the chlorine, hydrogen chloride is formed. In the same way, when sodium reacts, NaCl is formed. When H2 reacts, hydrogen reacts with oxygen, H2O is formed. In the same way, when sodium reacts, Na2O is formed. H2S is formed. In the same way, Na2S is formed when sulfur reacts with hydrogen and sodium. So here when you will see, students, when you will see, just a second, students, I'll move to the table. I'll move to the table and I'll explain you here. Students, when you will see table, here hydrogen is showing the same property as a sodium. Hydrogen is showing same property as a sodium here. So here hydrogen is showing the same property as in group 1, as of the elements of group 1. One example is already shown to you, that is sodium. In the same way, let us see the property of hydrogen with the seventh group. Students, we'll move to our slide here. When you will see here, students, when you will see here elements, see, molecular formula of hydrogen is H2, and at the same time molecular formula of chlorine is Cl2, students. Here hydrogen is compared with chlorine. Now when you will see compound with metal, students, when you will see compounds with metal, hydrogen when reacts with metal, NaH is formed, students. NaH is formed, you can see. In the same way, when chlorine reacts, NaCl is formed. NaCl is formed. So here we are comparing hydrogen with the Cl. Here we are comparing hydrogen with chlorine, students. See, when hydrogen reacts with carbon, CH4 is formed. In the same way, when chlorine reacts with carbon, CCl4 is formed. So here, students, hydrogen shows the same property as chlorine also. Hydrogen shows the same property as chlorine also. I'll repeat, students. I'll repeat, students. When we'll compare hydrogen and chlorine, hydrogen H2Cl2, chlorine Cl2. When hydrogen reacts with sodium, NaH. When chlorine reacts with Na, sodium, NaCl. When hydrogen reacts with carbon, CH4. And when chlorine reacts with carbon, CCl4. So here chlorine and hydrogen are showing same properties, students. Chlorine and sodium is showing the same property here. When you will see, students, chlorine, one element is selected and compared with the hydrogen. Now when you will see, hydrogen is showing the same property as group 7 also. So here hydrogen is showing the same property of group 1 and group 2 both. Group 1 and group 2 both. So here when group 1 and group 7 both are having same property, matching with the hydrogen, so where should we keep hydrogen was the biggest problem for when we are talking about med leave. And this was again a demerit, and because of these demerit, students, the law was not law, the theory was rejected and the new theory came forward, and this theory was given by the scientist name is Moseley, students. Henry Moseley. Here you can see the image of Henry Moseley. And next lecture, students, will continue with the modern periodic law with the scientist name, under the scientist name Henry Moseley, students. So till now, for today, I'll stop my lecture here only.